intro.
Hi guys, welcome back to 50th part of the Arduino tutorials. In my previous videos, we have worked on many analog sensors. So in this video, we'll be exploring one more, which is the force sensor. So before we start with the code and the practical things, we'll try to understand the basic working of this sensor. This is technically known as force sensitive resistor, which means the resistance of this sensor varies based on the force applied on the surface. Internally, it will have thin layers of conductive and resistive materials. So by default, it will be offering very high resistance, and when the force is applied, the resistive layer comes in contact with the conductive layer and the overall resistance decreases. So in order to interface with the analog pin of the Arduino board, we need these resistance values in terms of voltage drops, which we can easily achieve with the help of simple voltage divider circuit. So this is all about the working concept. In this tutorial, we'll try to interface this sensor with the Arduino board, print the analog values on the serial monitor, and also at the end, we'll be controlling the LED brightness based on the force applied. So for this tutorial, you need an Arduino board, force sensitive resistor or force sensor, one 10 kilo ohm resistor, LED bulb, breadboard for easy connections, and some jumper wires. Coming to the connections, first I'll take the 5 volts and ground of the Arduino board onto the breadboard. One terminal of the sensor goes to the 5 volts and the second terminal to the ground through a 10 kilo ohm resistor. So we have to measure the voltage drop across the resistor. So this connects to analog pin A0 of the Arduino board. For reference circuit diagram, you can visit the link from the description box. So now we'll start with the coding. First I'll declare the pin used for the sensor, which is sensor pin, and connect it to analog pin A0. In the setup function, I'll initialize the serial communication with a baud rate 9600. This is because later we have to print the values on the serial monitor. And in the loop, we have to just read the pin A0 using analog read function. And here sensor pin. So the values which are reading from this function to be stored in a variable, which I'll declare at the top. And I'll also print the same on the serial monitor. So this is up to the reading and printing the sensor data. So using this data, you can add some extra logic and determine different states. So I'll take if statement. If sensor data is less than 20, I'll print no pressure applied. Else if sensor data is greater than 21, logical AND. Sensor data less than 500, we can say light pressure applied. And in the next else if the sensor data is greater than 501 and less than say 800, I'll make it medium pressure. And in the remaining case, which is else, I'll make large pressure applied. So these are just approximate values I've considered just by observing the sensor values on the serial monitor. So these are not standard values. So you can change these values by doing multiple tests on your sensor. And at the end, I'll just keep some delay. So this is the code, which is very simple. We'll upload this and see the results. After uploading, I'll open the serial monitor. As we can see here, based on the pressure applied on the sensor surface, the ADC values are getting updated, and also it's showing the state whether it's light, medium or large pressure. So this is all about the basics. Now we'll interface an LED bulb and try to control the brightness based on the pressure applied. So before we proceed further, make sure you check out our previous tutorials on PWM concept and LED fading. I leave the link in the I button and description. To add LED to the circuit, connect the positive terminal to digital pin 3, which is a PWM pin, and the negative terminal to the ground. And coming back to the code, I'll declare one LED connected to digital pin 3, and in the setup function we have to set the pin 3 as output using pin mode. In order to control the brightness of the LED, we have to generate the PWM signal on digital pin 3, which can be done using analog write function. The pin is 3, and here we have to pass the value of duty cycle, which ranges from 0 to 255. So this value we have to derive based on the sensor data. For that, we can directly use map function. We are mapping this sensor data, which is in the range of 0 to 1023, and we need the output range in 0 to 255. So this we can store in a variable and pass the same in the analog write function. And also I'll declare the same here. So that's all the logic. So let's upload this code and see the working. So by default, LED is off, and once I start applying pressure on the sensor, the brightness is also changing accordingly. So that's all about the force sensor and its working. I hope this video was easy to follow. For code and circuit diagram, visit the link in the description box. And in the upcoming video, we'll be making a very interesting project with the same. Stay tuned, and for more updates, subscribe and follow us on Instagram. Thank you for watching. We'll be back in the next video.